Okay, so morning, Friday, if you're watching this Friday, not, hello. We are doing the law of sines. So our objective today is to use the law of sines to solve triangles. If we think about the types of triangles there are right triangles, acute, obtuse. What else are there? There are equilateral, isosceles. I mean, we've got quite a lot. So isosceles, equilateral, scalene, so there are a lot of different type of triangles. And what we've done so far is just solving right triangles. And we know when we solve right triangles, we could do our trig functions. So sine, cosine, tangent. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So if we were to solve this right triangle, we also know that with right triangles we could use Pythagorean theorem. So to find side length C, we go c squared equals 3 squared plus 6 squared. So then if we do that, we'd get 9 plus 36, which is 45. So c squared equals 45. And then if we square root 45, we'd get 3 square root 5. So we need to know c equals 3 square root 5. Then, in order to find a missing side length, or sorry, to find an angle, let's say angle B. So if we want to find angle B, we can do opposite over adjacent. So we could do tangent of B equals opposite over adjacent. And we know to get rid of tangent, we use inverse tangent or arctangent. So B equals inverse tangent of 3, 6. And I'm going to make sure my calculator is in degrees, just so that my answer is in degrees will be easier. So tangent inverse of 3, 6, or 1/2, and that is going to give us B is about 26.6 degrees. Then we could go to find angle A. We know angle A is going to equal 90 minus 26.6. So 90 minus 26.6, and we're going to get 63.4 degrees. Okay, so we've got A is 63.4 degrees. We got B as 26.6 degrees, and we've technically solved the triangle. But what if we have a triangle that's either acute or obtuse or scalene? That triangle requires a little bit more work. So we have what's called the law of sines. Law of sines says that if ABC is a triangle with side lengths ABC, so if we had a triangle A, B, C, and we had side lengths little b, little a, little c, across from angle C will be side length C. Across from angle A, side length A. Same, angle B, side length B. Then what we can do is we can write a ratio. We can write A over sine of A is going to equal B over sine of B, which is actually also the same as C over sine of C. So we're setting up a bunch of ratios. It is true also for the reciprocal. Reciprocal saying that if I have sine of A over A, that's going to equal the sine of B over B, which is going to equal the sine of C over C. So what we could do is use these ratios to actually solve a triangle. So if we look at letter A here, solve the triangle, first thing I'm going to do is find this missing side length, or sorry, missing angle, because I know all angles in a triangle add up to 180. So I'm going to do 180 degrees minus 80 degrees minus 60 degrees. That should give me angle C. Okay, so we have 100 minus 60, so that should be 40 degrees. So angle C equals 40 degrees. Okay, so then with our side lengths, I can't do Pythagorean theorem, and I can't use my sine, cosine, tangent like we did with the right triangle because we don't have a right angle. So we're going to use our ratio. We have angle A and side length A. So I could say 5.25 over 60 equals, and then I could pick either B or C. So I have little b here, and I'm actually going to do that one. So I could go B over sine, oops, I forgot my sine, sine of 60, sine of 80. Okay, so I have my ratio, and then what I could do is I could cross multiply. So that's going to equal B sine of 60 equals 5.25 sine of 80. Okay, so if you look at this, 5.25 sine of 80, that's just a number. So again, my calculator is still in degrees, but I need to solve for B, so I'm going to divide this by sine of 60. So B equals 5.25 sine of 80 divided by sine of 60. And I'm just going to go ahead and stick that in my calculator. Again, in degrees, 5.25 times sine of 80 divided by sine of 60. And I get B is about 5.97 centimeters. Okay, so B equals 5.97 centimeters. Okay, so then we have one more side length to solve for, and we are going to solve it the same way. So we're going to set up a ratio that allows us to solve this. Okay, so we're going to set up, I'm going to use the 5.25 sine of 60 again, but this time I'm going to equal it to my C value, so C up here. So that would be C over the sine of 40. Okay, so C over the sine of 40. So again, cross multiply. So we're going to cross multiply. 5.25 sine of 40 equals C sine of 60. And if you noticed, I kind of switched positions. It doesn't matter when you cross multiply which one comes first. We're going to then divide sine of 60 off to get C by itself. And again, in my calculator, so C is going to equal, I'm going to take 5.25 sine of 40 this time and divide it by sine of 60, and that's going to give me 3.9 if we round centimeters. So there is one answer. There's my second answer, and then I got my angle as 40 degrees. So we have solved the triangle.